First off, I would like to say that I'm wearing a blue shirt, not a green shirt, but my recording software does not care. So neither will I. Let's do some homework problems for Unit 8. We're going to start with number 1, which isn't really even Unit 8 at all, but let's go. It's known that 64%, it is known that 64% of Americans personally worry a great deal about federal spending and budget deficit. Okay, we have some kind of assumptions, some kind of status quo, some sort of knowledge about what we think is reality, 64%. Which of the following needs to be satisfied in order to be able to use the central limit theorem to describe the sampling distribution of the proportion of Americans who worry about this? So, we're looking at a sampling distribution of proportions. This whole unit, in Unit 8, we're talking about hypothesis testing for proportions, which means we're using a sampling distribution for proportions. In the final project, you may have questions about sampling distributions of means, in which case, and hypothesis testing for means, those will be connected. So we're going to go back to Unit 6. And in your Unit 6 notes, if you pull them up, hypothetically, you could see that there were 3 conditions: independence, randomization, and success failure condition, which is basically your sample size condition. Right? They are under 6D, I believe. Under 6E. Right here. So you can find those. So the sample needs to be random. That's true. Literally every multiple choice option has number 1, so we know it's true. The subjects must be independent. That part's true. If sampling without replacement, so with replacement means it's independent already, but if we're doing it without replacement, the sample size needs to be less than 10% of the population size. Yeah. So if we're doing without replacement, it's already independent. But if we are not replacing, then it's not independent. But the 10% condition, which I don't remember what unit we introduced the 10% condition, but we talked about it again in Unit 6, says that even if this sample is only 10% of the population or smaller, then without replacement and with replacement are close enough to the same thing that we can say it's independent enough. So 2 is right. All right, so we're down to these 4 options. What about 3? Sample size should not be less than 50. No, it depends. It depends. We need at least 10 successes and failures, but I mean, I guess that could be a sample size of 20, depending on what the proportions were. The 3 is not true. So this third option's out. It's going to be option 2, 3, or 2, 4, or 5. The expected, not 2, either 4 or 5. The expected numbers of those who do and do not personally worry need to be at least 10. Yeah, so 3 is not true, but 4 is true. We want at least 10 failures and at least 10 successes. And that's what that's talking about. So, should be our answer. Great. I got it right. Next up, let's look at number 2. You're conducting a study, and you're trying to see if the proportion of voters who prefer candidate A, nice name, is significant. Cat hair in my mouth. Is significantly less than 0.23. If your null and alternative hypotheses are P equals that and P less than that, what kind of test are we using? I'm going to say a quick word about null and alternative hypothesis. If we translate this equation in English, it says we believe the population proportion is 0.23. Null hypothesis, that assumption. We are testing if this population proportion is actually less than 0.23. So these can be translated into sentences. So we're looking to the left. Are we less than 23? That's to the left. The left tail test. Visually, what we have here, right, is we have some normal distribution. We have some normal distribution, and we're curious if it's less than some amount. Well, less than some amount. Look, that is going to the left. Okay, my cats are racing around. If they unplug this, I'm going to lose my mind. All right, so that's good on number 2. Let's do 2 more questions. Let's do some big ones. A well-known brokerage firm executive claimed that 30% of investors are currently confident of meeting their investment goals. Okay, 30% are confident. That's a claim. That's a null hypothesis. I can already say P is 30%. An XYZ investor optimism survey, which was conducted over a 2-week period, found that in a sample of 700 people, a sample, that's our sample size of 700 people, 36% of them, okay, we took a sample and we found a sample proportion of 36%, said they were confident. Okay, so again, this is the claim, this is the sample, this is the sample size, and we're wondering if this is significant. So we're testing the claim that the proportion of people who are confident is larger than 30%. We have a pretty small significance level here. We want to be confident. If we disagree with the 30%, we want to be confident. The bigger the significance level, the less the significance is kind of... Hold on, that's not a good way to say it. The higher the significance level, the less sure we need to be. The lower the level, the more sure we need to be in order to reject this claim. So again, this executive is claiming this. We tested that, and we're saying, what are the chances, or do we think this executive is full of crap? That's what we're testing here. So the null and alternative hypotheses are, some of these are making claims about mu. We're looking at proportions here. We're looking at qualitative data, categorical data. Are you confident? Are you not confident? So all the answers with means are out. And specifically, again, I think multiple choice is easiest just to do it yourself and then pick the right one. The null hypothesis is that we believe the population proportion is 0.3. That's his assumption, or their assumption, the executive. The alternative is what we're testing. Are we testing that it's bigger than, less than? We're testing that it's bigger than 30%. So that's our answer here. That's going to be this guy over here. What kind of test is it? Well, all you have to do to figure out what test it is look at the alternative hypothesis. We're looking at greater than some number. Look at a number line. What does greater than 0.3 look like? Looks like that sort of thing. It's going to the right. The right-tailed test. What's the test statistic? Well, that takes a bit of work to get there. So let's just go through the hypothesis test. We got to make sure central limit theorem is satisfied. Okay, let's see. Are we doing a random sample? Yeah, we can assume this is a random sample. Is it independent? Yeah, we're sampling without replacement anyway, so we don't need, or with replacement anyway, so we don't even need to worry about the 10% condition, but that would be satisfied. Success failure condition, yeah, we're asking 700 people. So 700 times 36%, going to be way more than 10. And the failure is going to be even more than that. So we can use the central limit theorem. We know that p hat is going to be normally distributed with a mean of p and a standard deviation of pq over n in a square root. So let's find what those are. P is 0.3. What's the standard deviation? Square root of 0.3. Q will be 0.7 here. If 30% are confident, 70% are not confident. And 700 people, we'll type that into a calculator. All right, I'll use GeoGebra Scientific Calculator, square root of 0.3 times 0.7 divided by 700 is 0.01732. Includes at least 4 significant figures. And if you run into some issues with MyOpenMath, then try including some more significant figures. All right. But 4 significant figures should be good for most of the time. So that's our standard deviation, 0.01732. So we expect about 30%. And one standard deviation is about 1.5%, 1 3/4%. Pretty small. So how many standard deviations away from the mean is our sample? Assuming the null hypothesis, assuming this executive's claim is correct. I don't know, it's like 4 standard deviations above or something. It's pretty rare. So what's the test statistic? Z star. We just need to convert our sample, find the z-score for the sample, basically. So our value minus the mean, all divided by the standard deviation. This is just calculating z-scores, just like we did in Unit 5. Let's approximate that. And again, if you want to use this number up here, just like copy and paste it, you get a more exact answer. But I'm going to see if 4 sig figs will make MyOpenMath happy here. We had 0.36. How far is that from 0.3? Make sure to include parentheses. Divided by 0.01732. We'll get 3.4642. We'll type that in somewhere. Oh, 3 decimals at once. So 3.464. All right. And then we use that to find the p-value. So what's the probability? We have a right-tailed test. What's the probability? This is our z-score. Test statistic is z-score. What's the probability that we're 3.5 standard deviations above the mean? That's a tiny probability. That's so small. That's the p-value. The p-value is what's the probability that something this crazy or crazier could have happened. We're only looking at right-tailed tests, so we're just looking at bigger than this, not less than anything else. We can show that with GeoGebra. We found our z-score, so we don't need to change the mean and standard deviation, although we could. What's the probability that we're at least 3.424? Was that it? 464, sorry. Yeah, it's almost impossible to be 3.5 standard deviations above the mean. Our p-value is 0.0003. P stands for probability. P means a lot of things in this class. All right, that's 4 decimals. Then we reject the null hypothesis. If the p-value is low, the null must go. This is so rare to have happened. It's possible that this could have happened, but it's so rare that it makes us doubt our assumption. It makes us doubt this claim. Because the chance of getting a sample this big of 36% with this sample size, so rare to get 36% or more. So we think this executive is full of garbage. All right, let's see how I did. Great. I'm going to walk you through one more. This video is going to be kind of long, but this section's kind of long. So I want to give you guys the option for more problems if you want them. But again, this video is completely optional. So feel free to pause, take a break, take a stretch, go for a walk. Many investors and financial analysts believe the Dow Jones Industrial Average, the DJIA, gives a good barometer of the overall stock market. I was talking to my friend who's really into stocks about this problem, and he's like, I do not believe that's a good barometer. Anyway, on January 31st in 2006, way back when, wow, that's problem. This data is old. 9 of the 30 stocks making up the DJIA increased in price. All right, I don't know how to write that down, but let's write something down. 9 out of 30 increased January 31st, 2006. I don't know how we're going to use that yet. Well, I do, but you wouldn't if you hadn't seen this problem before. Okay, but it looks important. All right, and that's according to the Wall Street Journal, February 1st edition. On the basis of this fact, a financial analyst claims that we can assume that 30% of the stocks traded went up the same day. Analyst claims 30% went up on that same day. Okay, is 30% 9 out of 30? Well, you can check. That's an important question to ask. Yes, it is. The 9 out of 30 is just 30%. That's where that claim is coming from, on the basis of this fact. So that's why they took this first piece of information, and that analyst went to that second piece of information. That's how those are connected. And then we took a sample. Ooh, I love seeing this word. I love seeing this word. This tells me something. A sample. Okay, we're thinking about n's, thinking about p hats. So they made that claim of 30%, but then we took a sample of 75 stocks. Oh yeah, that's an n for sure. Sample of 75 stocks showed that 31 went up. So that's not our p hat, but it's close. What is p hat? Well, p hat is the proportion. 31 went up out of 75. That's our p hat, which I don't think it reduces. I think 31 is prime. I don't know. It's certainly not divisible by 5 or 3. So this doesn't reduce. All right. We use a significance level. Oh, we're conducting a study to see if the proportion of stocks that went up is significantly more than that analyst claimed. Again, 31. What is 31 out of 75? 0.413 repeating. Oh, so the claim was that 30%. And now we do know that that is the claim. The claim was that 30% went up that day. If the Dow Jones, the DJIA is indeed a good barometer, then the analyst would say that, 30% are going to go up. But when we actually did the sample, way more than 30% went up. Or we're going to find out whether it's way more. It's more. But the sample size was only 75. So is this way more? I don't know. We're going to find out. And so that's what we're testing here. Is it significantly more than? So right off the bat, I know our hypotheses, right? Our null is our assumption from this analyst that the proportion should be 30%. Our alternative is what we're trying to test. We're trying to test whether it's more than 30%. Alpha is 0.02 here. What is the test statistic? All right, and so ideally you just use the exact p hat, the fraction form. But here this problem is specifying that if you use p hat and sigma rounded to 5 sig figs, and your answer to 4 decimal places, then you'll get what my open math wants. Let me know if you have any trouble with that. So if we're rounding to 5 sig figs, this would be 0.41333. And our sigma, that's their standard error. We're going to need that, well, check the central limit theorem. And it'll go through checking just like we did in the last example. And we get that we can use a sampling distribution of proportions, where the mean is our assumption, 0.3. And the standard error, or standard deviation, is going to be the square root of PQ over N. which is the square root of 0.3 times 0.7 all over n, which is 75. Type that into a calculator. We get something very similar to what we got over here. Now it's 75. 0.052915. They said 5 significant figures for our standard deviation. So that's how we're going to write it. All right, so 0.052915. This is how the sampling distribution should work, assuming this analyst is correct. We expect 30% with a variation of about 5% for the sample size. So really, we're only about 2 standard deviations above the mean. 41% is about 5% above. So that's rare. Is it rare enough? We're going to find out. We're going to find the z-score. The test statistic, again, is just the z-score. It's saying we have some data, we have a distribution, how many standard deviations above or below the mean is that? So it's going to be our value, which again, the problem told us to round like this, minus the mean divided by the standard deviation. And it wants us to round this answer to 4 decimal places. So we do that. Make sure to include the parentheses, 0.41333 minus 0.3, all divided by 0.052915. 2.1417. We expected it to be about 2 standard deviations above the mean. Yes, we got a number close to 2. It is about 2 standard deviations above the mean. I already forgot the number. 1417. What's the p-value? Well, what's the chance that we are, the p-value again, this is actually maybe good practice to write this down. The p-value is just the probability of this sample happening. The probability that our test statistic is at least what our sample was, 2 standard deviations above the mean. So we can find probabilities of standard normal variables like so. 2.1417. That p-value is about 0.0161. Did it say 4 decimal places again? I think it did. So, is this p-value less than alpha? Yeah, alpha is 0.02. This is 0.01 something. Yep, it's less than alpha. So, if the p-value is low, then null must go. So we reject the null hypothesis. We reject this analyst's claim. This null hypothesis was the analyst claiming that 30% would go up. We're saying this is enough evidence. This number is big enough to make us doubt this claim. So how do we put that into words? Sometimes the multiple choice ones on these are a little weird. There is sufficient evidence. That's all right. So that part is right. There is significant evidence to reject that claim. To warrant rejection of the claim that the proportion of stocks that went up is more than 0.3? No, we're rejecting the claim that the proportion that went up is 0.3. Oh wait, this is also not that though. Sufficient evidence to support the claim that the proportion that went up is more than. Gosh, the wording in these is so weird. We're rejecting that it is 0.3. So we're supporting that it's more than 0.3. It should be this one. Great. We got it. Let me know if you have any questions. Good luck. Have a great rest of your day. What shirt is this? Oh, this is my science fair shirt from helping for a high school and junior high science fair in Wyoming. It's also the shirt I use while mountain biking in the mud and the thunderstorms in northern Utah. It's very stained. If I paint, this will be my painting shirt. Only the highest of quality shirts for this green screen stream. I guess I'm not live streaming it, even though I'm using live streaming software. It's on YouTube. Anyway, have a great day. Bye-bye.